So welcome to this class. And this session, we are going to give the formal definition of a limit and then prove some limits using this definition. So let's start the definition. So let f of x be defined on an open interval about a point x equals to a, but not necessarily at x equals to a itself. So let f of x be a function defined on an open interval about the point x equals to a, but not necessarily that the function must be defined at the point a itself. So we say that the limit of f of x as x approaches a is the number L and we write limit f of x x approaches a equals to L if given a for every number, every positive number, epsilon, there exists a corresponding positive number called delta number delta such that for all x this x minus a lies between 0 and delta whenever or implies f of x minus L is less than the epsilon. So this is the definition of formal definition of a limit. But we assume that a function f of x is defined in an open interval about a point x equals to a, not necessarily at the point a itself. Then we say limit of the function f of x as x approaches a is the number L, and this we write lim f of x, x approaches a equals to L, a for every positive number epsilon. The key thing here is this number is positive. There exists a corresponding delta, which is also positive, such that for all values of x, then the absolute value of x minus a lies between 0 and delta, and then absolute value of the, that implies that absolute value of the function f of x minus this value L we are claiming is the limit is less than epsilon. This is what you are trying to say. So if you draw a graph, assume this is the function of interest. This is an arbitrary function, f of x, y equals to f of x. So if my point A is at this point here, then if I pick a small distance, delta, so this is delta, so this point will be A plus delta, and then same to the left will be now A minus delta at this point. So if I go to my graph, this is a point A, so this A, the values of the graph, remember, are read on the y-axis. So this way I have my L. So this small delta on X have this. So when you project the same to the y-axis, so causes now on the y is epsilon. So this point will be L plus epsilon. And then this one, so this still also epsilon. And then this point will be L minus epsilon. So we are saying that any small change in X value here will lead to a corresponding change in the Y value. So that's why I'm saying that if you have for every epsilon change in this Y value, then it implies there's a corresponding delta on the X-axis that caused that change. So, and this delta and this epsilon are both of them are positive, and then they are very small, small quantities. So any small change in X here will lead a small change in Y here, or a small change in Y was caused by another another change in the X value. So let's now prove some limits using this formal definition. So prove using epsilon delta argument that let's start with just a simpler one. Limit as X approaches 1 of 2X plus 3 is 5. For this, this is how we structure the proof. So I start by assuming that there's this small positive number epsilon that has already caused a change in Y. So we say, let's assume that epsilon greater than 0 is given such that there corresponds a delta greater than 0 so this is given such that there corresponds a delta greater than 0, so that this difference between x minus a less than delta implies that f of x minus L is less than epsilon. Now, our case here, f of x is 2x plus 3, our L is 5, and our A is 1. So therefore, we say x minus 1 must be less than delta. So call it equation 1. And then, so our f of x, which is 2x plus 3 minus L, which is 5, this must be less than epsilon, which implies that 2x minus 2 is less than epsilon. And then this implies that 2 into x minus 1 is less than epsilon. And this means that absolute value of 2, absolute value of x minus 1 is less than epsilon. Absolute value of 2 is just 2, so 2x minus 1 less than epsilon. So which means x minus 1 is less than epsilon over 2. So call this one equation 2. So equation 2 and equation 1 are the same. So we say we choose delta to be epsilon over 2. And then we are done. So because now, so this, remember, even any smaller value than this one still works. So delta is less than or equals to epsilon over 2, or simply delta equals to epsilon over 2. So that's the proof of that. And number 2, limit as x approaches 3 of 2x minus 4 equals to 2. So this is say, so proof. Let epsilon greater than 0 be given. So this one, we assume that already is given there. So we find a delta greater than 0 such that x minus a less than delta implies f of x minus L is less than epsilon. So we have our a is 3 for this case. So x minus 3 is less than delta. Can call it equation 1. And then f of x minus L is the same thing as saying 2x minus 4 minus 2. This will be less than epsilon. And then 2x minus 6 is less than epsilon. You do factorization, 2 into x minus 3 is less than epsilon. And then, so this is the absolute value of 2, absolute value of x minus 3 is less than epsilon. So 2x minus 3 less than epsilon. And then this means that x minus 3 is less than epsilon over 2. So so if you say call this one equation 2 and then compare with equation 1, then if we choose delta to be the same as epsilon over 2, then we are done. Also, equation 1 and equation 2 have the same values on the left-hand side, so right-hand sides can be equated. So that's what we have. And then number 3, limit as x approaches 2 of minus 2 minus 3x plus 4, say plus 14, equals to 8. So proof of this, so you say let epsilon greater than 0 be given or chosen. So the objective is that we find, we need to find a delta greater than 0 such that absolute value of x minus a less than delta implies f of x minus L is less than epsilon. So that's the stem of the proof. So we say x minus 2 is less than delta. So because A, we already have it, so call it equation 1. And then f of x is minus 3x plus 14. L is minus 8. And this must be less than epsilon. So minus 3x plus 14 minus 8 is plus 6 is less than epsilon. And if you do factorization, you'll have minus 3 into x minus 2 is less than epsilon. Remember, you do the factorization so that now what you have should be the same as this x minus 2. So this is the same as absolute value of negative 3 x minus 2 less than epsilon. And absolute value of minus 3 is positive 3. So 3 into x minus 2 less than epsilon. So x minus 2 less than epsilon over 3. So call this one equation 2. So from equation 1 and equation 2, we choose delta to be epsilon over 3, then we are done. And then the last example, 4, limit as x approaches 2 of x squared equals to 4. So here, as usual, the proof will start as let epsilon greater than 0 be given. So we find a delta greater than 0 such that x minus a less than delta implies f of x minus L is less than epsilon. So our a for this case is 2. So therefore x minus 2 is less than delta. Call it equation 1. And then here we have absolute value of f of x, which is x squared minus L, which is 4, less than epsilon. We discover that these are difference of two squares. So x squared minus 2 squared this will be x minus 2 or x plus 2, x minus 2, the factorization of the difference of two squares. So here we have x plus 2 and x minus 2 less than epsilon. So we know that we need to have absolute of x minus 2. So we need to do away with this term here. But remember, this x is a variable. So it's not just like the previous one where we are dividing through and then you say, let delta be given by this value depending on epsilon. So here we have to ensure that x minus 2 is as small as we can, as we can, so that now the small change in y should be very, very, remember this epsilon is a small number, and then this change x minus 2 in the x-axis will also be a very small number. So we do this by saying, let's assume that delta is less than or equals to 1. So then this means that x minus 2 is less than or equals to 1, which means the definition of absolute -1 less than or equals to x minus 2 less than or equals to 1. And so we solve this inequality. So we have -1 less than or equals to x minus 2 and x minus 2 less than or equals to 1. So here we have -1 plus 2 less than or equals to x, x less than or equals to 1 plus 2. So we have 1 less than or equals to x, x less than or equals to 3. So it's like x lies between 3 and 1. But remember, for us to have x minus 1 absolute in this line here, so we need to be dividing by, at this point here, we need to say x minus 2 is less than epsilon over x plus 2. And for us to have this, to ensure that this value is as small as we like, this one here, then we expect the right-hand side to be a very, very small number. And this will be a small number when the denominator is a large number. And so with these two values of x, 1 and 3, 1 and 3, the one that will make x plus 2 to be larger is when we pick 3. So therefore we say 3 plus 2 to give us 5. So therefore we say absolute value of x minus 2 is less than epsilon over absolute value of now 3 plus 2, which is the same as over 5, i.e. x minus 2 is less than epsilon over 5. All this one equation 2. But now you see here, there are two things. Remember, we have to relate to get the value of delta, which is positive and as small as we can. But you see, if you compare equation 1 and equation 2, then you can say delta equals to epsilon over 5. But before you go to this epsilon over 5, we have already assumed that delta is greater than, less than or equals to 1. So there'll be two values of delta, 1 and then this epsilon over 5. Because we don't know the value of epsilon, so therefore, so that to ensure that the delta we are picking is very, very small, then we'll say we choose delta to be the minimum of these two values, 1 and this epsilon over 5. Because we don't know whether 1 is the smallest or the epsilon over 5 is the smallest. So just say choose delta to be a minimum of either 1 that we assumed or this epsilon over 5. Then we are done. So know the difference between proving when we have a quadratic function and when we have linear function. So for quadratic function, our value of delta that you pick is a minimum of the two values. One you'll assume for delta and then the one that you get after that assumption. So thank you.